In this video, we are going to discuss how to calculate the electrostatic force on a charge using superposition principle in two dimensions. The question says three charges are located at the position shown in the figure. Q1 is equal to negative 4 times 10 to the power negative 8 coulomb. Q2 is 8 times 10 to the power negative 8 coulomb. And Q3 is 6 times 10 to the power negative 8 coulomb. Calculate the force acting at the charge Q2. So here you have three charges as shown in the figure. Q1 is located on the y-axis, 0.8 meter. Q2 is at the origin, whereas Q3 is on the x-axis, 0.6 meter. We need to find what is the net force on Q2 because of charge Q1 and Q3. Before we find the magnitude of the force, we need to first sketch the direction of forces acting on Q2. Now Q2 is a positive charge, whereas Q1 is negative. So Q2 will be attracted to Q1. Therefore, force on Q2 because of Q1 will go in direction of positive y-axis. That is, it will point up like this. So this is my force F12. Force of charge 1 on charge 2. Q3 on the other hand is a positive charge. So it will try to repel Q2. So because of Q3, Q2 will be pushed away towards left, and this is the direction of force on charge Q2 because of Q3. We write this as F32. We can sketch the resultant of these forces by using the law of parallelogram. If this two vector represents two sides of a parallelogram, we can find the resultant by completing the other two sides and drawing a diagonal for the resultant. This is my Fnet. In order to calculate Fnet, we need to first find the magnitude of these individual forces, F12 and F32. So we can write F12 as K Q1 Q2 over R12 squared, where R12 is the distance between Q1 and Q2, which from the figure is 0.8 meter. So let's substitute the value. K we will take as 9 times 10 to the power 9. Q1 is negative 4, but while calculating Coulomb's force, we are going to ignore this negative sign. 4 times 10 to the power negative 8. Q2 is 8 times 10 to the power negative 8 over 0.8 squared. And when you solve this, you get F12 to be equal to 4.5 times 10 to the power negative 5 Newton. We do the same thing to find F32. We write F32 to be equal to K Q3 Q2 over R32 squared. R32 is the distance between Q2 and Q3, which is 0.6 meter. So let's substitute. K is 9 times 10 to the power 9. Q3 is 6 times 10 to the power negative 8. And Q2 again is 8 times 10 to the power negative 8 divided by 0.6 squared. And when you do this, you get F32 to be equal to 1.2 times 10 to the power negative 4 Newton. Now these two forces are perpendicular to each other. And whenever two forces are perpendicular to each other, we can find their resultant by using the Pythagorean theorem. So I can find Fnet as square root F12 squared plus F32 squared. So let's substitute. This will become square root 4.5 times 10 to the power negative 5 squared plus 1.2 times 10 to the power negative 4 squared. And when you solve this, you get F net to be equal to 1.28 times 10 to the power negative 4 Newton. So this is the magnitude of the resultant. After we find the magnitude of the force, we need to find the direction. So direction we find using tan theta. We write theta equals tan inverse of y component of the force over the x component, which is equal to tan inverse. The y component of the force is F12, which is going along the y-axis. So we write F12 over x component is F32. Now substitute. Theta will be tan inverse of 4.5 times 10 to the power negative 5 over 1.2 times 10 to the power negative 4. That gives me the value of theta to be equal to 20.55 degree. Now this theta that we calculated here is the angle my resultant makes with the negative x-axis here. But usually when we are finding the angle any vector makes, we have to find that angle from positive x-axis. So we need this angle, which I will call theta final. And by looking at the figure, I understand that we can find theta final by subtracting theta with 180. So let's do that. 180 minus 20.55. That gives me my final angle as 159.45 degree. So therefore, I can write my final answer as the resultant force F net is 1.28 times 10 to the power negative 4 Newton, making an angle of 159.45 degree with the positive x-axis.